Bismillahirrahmanirrahim. Now we'll construct polynomials for GF of 16 with primitive element x. We will construct GF of 16 polynomials for GF of 16 using uh, primitive element x and x squared both. So first we see that highest polynomial degree for GF of 16 is m minus 1 is equal to 4 minus 1 is equal to 3. And the generator polynomial which we will use will be alpha or alpha square plus alpha plus 1. Here we are using alpha in place of x, and it doesn't really make much difference. Using primitive element alpha, or alpha 4 is equal to alpha plus 1. Multiplying by alpha and substituting alpha plus 1 for alpha 4 and adding the resulting terms, we get complete field for G of 16 as shown in the table. So for first one, first element is 0, then we begin alpha is power 0 is equal to 1, alpha 1 is equal to x, as we know that alpha 1 is simply the x in this case, and alpha square is equal to, we simply break this alpha square into alpha, where each alpha is equal to x. This is what we have assumed over here. Alpha x is equal to x. Here this primitive element is equal to x. So what we get is x square over here, and alpha cube is equal to alpha into alpha square. And now we will use the result of alpha square over here to find the value of alpha cube. So what is the result of alpha square? It is x square. So x square into alpha, which is equal to x, gives you x cube. Up to here we have no problem because the highest degree allowed is 3. And what we get over here for these polynomials 0, 1, x and x square and x cube, which is the highest degree. But for alpha 4, we have got x is power 4, which is greater than 3. So what do we need to do is that we need to reduce this, and to get the value for x4 we use this irreducible polynomial. We first set the value of irreducible polynomial alpha 4 plus alpha 1, alpha 4 plus alpha plus 1 is equal to 0, and then we find alpha raised power 4 is equal to alpha plus 1. So we simply put this x4 is equal to x plus 1, then alpha 5 is equal to alpha 4 plus alpha, where again we have used the value of alpha 4, which is x plus 1 over here, into alpha, which is x over here, and we get x squared plus x. It's okay because the highest degree is 2. Alpha 6 is equal to alpha 5 into alpha, again it is x cubed plus x squared, no problem. Alpha 7 is equal to x4 plus x3. Here we need to replace this x4, x raised to power 4, with x plus 1, and we get x cubed plus x plus 1. Then alpha 8 is equal to x4 plus x squared plus x. Again this x4, this power 4 is replaced by x plus 1, and finally we get x squared plus 1. Alpha 9 is equal to alpha 8 into alpha, and we get x cubed plus x. Here x squared plus 1, x squared plus x plus 1, and x cubed plus x squared plus x for alpha 11. For alpha 12 it is again x to the power 4, and replacing x to the power 4 with x plus 1 gives x cubed plus x squared plus x plus 1, and you can see the rest is the same method is used to find alpha 13 and alpha 14. These are the decimal values of these polynomials if you convert them into from binary to decimal. Now you can see that we can find some other polynomials if we use x square as our primitive element rather than x. Here we have just simply replaced the primitive element x square, x with x square. So highest polynomial degree will remain the same, which is equal to 3, and generator polynomial again the same, but the only thing is that the primitive element is now x square. So here again 0, 1 remains the same. Now you can see that alpha 1 is equal to x square. Why? Because you can see that here alpha is equal to x square. Alpha 1 is equal to x square. Now when you have this, break this alpha square into alpha, same as in the previous example. The difference is that now you will use x square into x square instead of x into x, because here alpha is equal to x square instead of x. So you get x square into x square is equal to x to the power 4, and as you can see that x to the power 4 is equal to x plus 1. So you get x plus 1 over here. Alpha cube is equal to alpha into alpha square. Again alpha is replaced by alpha x square, x, and alpha square is as x plus 1, and what you get is x cube plus x square. No problem over here, because in this one also the maximum degree has polynomial degree is 3. But when we get here, we get x is power 5 plus x to the power 4. The degree of both of these terms is greater than 3. So we break this x is power 5 into x to the power 4, and x to the power 4 is replaced by x plus 1. Again this x to the power 4 is replaced by x plus 1 over here, and what we get is x square plus x 1, which is equal to 2x. In modulo 2 we know that 2 becomes 0, so the final answer is x square plus 1. Here again the same thing, x to the power 4 plus x square. X to the power 4 is replaced by x plus 1, and we get x square plus x plus 1. And here again we have got one term which is greater than 3. So finally we get x cube plus x square plus x plus 1. And the same way we get the values for alpha 7, 8, 9, 10, 11. What we have to do is that simply we have to reduce the power of all the terms greater than 3, because the maximum allowed degree for this one, for GF of 16 or GF to the power 4 is 3. So the method is very simple. Simply break the terms which have got higher power into lower power, factorize them, find factors, and then you replace them with the lower power terms. So that is how we get the elements, all the elements from 16 elements from 0 to alpha 14. Now if we want to construct GF of 9, it will be a little bit different, because here the base will not be binary anymore. Now the base will be 3. So the total number of elements will be 0, 1 and 2, not just 0 and 1. So it is different. It is not the binary anymore. And here the maximum power for polynomial is also different, because here you have got maximum power is 2, and 2 is power minus 1 means the maximum power 1, means you cannot have any polynomial greater than degree of 1. And for f of 3 we use the irreducible polynomial, which is x square plus 1. And if we check this one for x power 3, for whether it is primitive or not, then what we get is that 0 square plus 1 is equal to 1, 1 square plus 1 is equal to 2, and 2 is power 2 plus 1 is equal to 2. Since for all values of 0 and 2, x square plus 1 is not equal to 0, it is irreducible, and hence x square plus 1 is equal to 0, which gives you x square minus 1, and as we know that this minus 1 becomes 2 in f of 3. You can see this is different. In modulo 2, minus 1 was equal to 1, but when we are talking about modulo 3, then it is different. It is minus 1 is equal to 2. So 0 gives you 0, 0 raised power, alpha raised power 0, 1, same thing. Here alpha 1 is equal to alpha 2 is equal to 2, and alpha 3 is equal to 2 break up, having factors alpha is power 2 and alpha gives you 2 alpha, and alpha 4 gives you alpha cube plus into alpha is equal to 2 alpha into alpha, which is equal to 1. Now since alpha 4 gives 1, which is already a polynomial, or alpha 0, we will not be able to get all 9 unique polynomials. The reason of this duplicate values is that x square plus 1 is an irreducible polynomial but not a primitive polynomial. This is the main difference. But if you have got a polynomial which is irreducible but not primitive, then you cannot get all the possible values. Values may duplicate. So instead of x square plus 1, we will use x square plus 2x plus 2, which is a primitive polynomial. So this is the main difference here. X square plus 1 is a irreducible polynomial, whereas x square plus 2x plus 2 is a primitive polynomial. Now if again we check for this one, if it is irreducible or not, then we get that it is irreducible. And what we get for this x square plus 2x plus 2 is equal to x square is minus 2x minus 2, and here minus 2 is equal to 1. So what we get is that x plus 1. So x square is actually equal to x plus 1. Now we again find the polynomials. 0 is 0, 0 is power, alpha is power 0 is equal to 1, alpha 1 is equal to alpha square is equal to alpha plus 1, because that's what we have seen over here. X square is equal to alpha plus 1, x plus 1, alpha plus 1. So x cube, x square into x is equal to alpha square plus alpha. Again, just replace this alpha square by alpha plus 1 and you get to alpha plus 1. And the very same method which we have used over here in these over here to find gf of 16, we'll use to find gf of 9. And what we get is that 0 1 alpha plus 1 2 alpha plus 1 2 and 2 alpha plus 2 and alpha plus 2. These are the polynomials we get, and we have got all the 8 elements. Sorry, 9 elements. So that's how we get all the 9 elements of GF of 9, and it is very simple.